Okay, now officially, good Friday morning to you guys. Today we're going to go over the homework or any homework questions you have. I don't have any sort of set plan for anything here, just for you guys to give me any homework questions. And then Monday we have a little test, small test to determine your grade. And so let me do this here. Study guide for chapter 3 test. Okay, so you guys, give you guys a minute here. Take your homework out. And I'm going to see if I can get something else up here. Geometry. It's not by name. There it is. All right, I am good to go on my side here. Let me just flip my computer around so I can write on it. Okay, you guys are still there. Good, good. All right, as far as taking role purposes, so I have it in my notes here. I got Corinna, Hayden on one side, Maya, Rylan, row 2, Georgia, Grace, and is it Nicholas? Yep. Okay. And then the unseen Grant, and then Adrian, and then Zechariah.
Well, Grant, yeah, Kiana is in between Grant and Adrian.
Okay, Kiana, Grant, Adrian, and Zechariah. Okay, perfect. We'll go with it. Just see if Grant makes any funny faces at me or something else like that, okay? It'll be like point deduction each time he makes a funny face. Okay, so let's do this here. Do you guys see my screen? Should have a Microsoft PowerPoint on top of it?
Yes.
Okay. I'm going to diminish this here. So let's go. Any homework questions? Let me put up the numbers here. So this is 3-1, 3-2, 3-3, 3-4, and 3-5.
We can even do that. He's pictures.
Yeah.
Did I get adjusted? Is that what happened?
Yes.
Thank you so much. Oh, a lot better. Yeah, I think so. Okay. Okay, and then I'm gonna zoom in. I got zoomed in on the class on the iPad, so you guys, I can see you guys better. Boom. Okay. All right. Talk to me here. Any homework questions come out of those?
Do you want us to start with 3.1 and tell you if we have any questions on that?
Let's do this. Yeah. Let's do just give me the section and then the problem, and we'll kind of do a big board so that I can see how much time we have.
So for 3.2, I had a question on number 21.
Okay.
And then also for 3.2, I have questions on 53, and then a few of them after that, but they're all related. So.
Okay.
And then in 3.3, I had a question on 89.
And also in 3.3, I had a question on 57 and 49.
3.3, Karina?
Yep.
Okay. All right. 3, 4, 3, 5. Too easy?
13 on 3.4.
Yeah, 3.5, I had a question on 21 and 44 and 45.
And 49.
And, okay. All right, I think that's our list. Let's go with it here. Honesty question. Here it goes, guys. Honesty question. How many have completed their homework up through 3.3? Pretty good, solid. Raise of hands or thumbs up, whatever you prefer. Ooh, okay. Gotcha. Okay, so there's some. So I think there's some weekend homework to do here, but let's see if we can get through some of these homework questions right now. So therefore, when you guys started, you guys will have easier time to do this here. Okay, let's jam. 3 point. I'm going to refer back to this slide here. I have it in front of me. But 3.2, number 21, and let's just go at it. I'm going to go trying to go fast, but you guys slow me down if you need to, all right? And so 3.2 says find the number of regular miles to the nearest hundredth of a mile. Oh, in a nautical mile. Okay, gotcha. Okay, so what a nautical mile is it's used in ships and accounts for the curvature of the earth as well. So whenever you go a mile, usually when you say Sloka's 20 miles away, we mean flat surface. If you're on a barge and you're traveling halfway around the world, you want to take the curvature of the earth into consideration here. So a little bit earlier, it says the central angle with the vertex, center of the earth, is measured by one, it's not a degree, that's 1 minute, is the arch and the surface of the cut off by that angle. So there it is. So 1 nautical mile, N-A-T, nautical, can't spell, here it is. Nautical mile is the earth measured off from the radius or from the center at 1 minute here. I think we have this little formula though. And let's see, I just want to make sure that it's what we looked at before. Yeah, okay, that's in the same section here. So we got, doesn't this look like arc length right here? From the side there, that looks like arc length. So we're just going to measure arc length based upon 1 minute as a degree. All right, the only little problem now is this guy is in terms of radians, not degrees. And we are, I'm flipping back and forth, and we are rounding off as well. So it says to round off this is 4,000 miles as far as the radius is concerned, even though it's a closer estimate is 3,960 miles, but the radius of the earth here, 4,000. And here's our little problem. We got to convert 1 minute into radian measurement. And so I know that 1 minute is 1 over 60, 1/60th of a degree. That's cool. We take 1/60th of a degree. We multiply it times pi over 180 degrees. And those should cancel there. Ooh, anybody, what is 60 times 180?
10,800.
10,800, Brenna?
Yeah, that's what I got.
Perfect, okay. Not that we don't trust you, but I just need to second that.
Second.
Okay, perfect. Now we're going to use that amount to plug into here. So pi over 10,800, and then the calculator, put that into and do it to the nearest hundredth of a mile. All right, should be a little bit over a mile, like 1 point, I don't know, maybe 1.2 or something along those lines.
Wait, no, you have to times it by. Oh, I got 1.16.
I believe that's about right, yeah. I think it's because we used 4,000. I think it's closer to 1.12, but we estimated on the radius of the Earth. That's why. So good to go. Okay, jamming. We're just gonna be jamming. I'm gonna try to finish this up here. We got what, half an hour? So let's jam. Again, I'm gonna go fast. You guys slow me down. And if you have any questions, please tell me.
I have a question just about like the calculators. How do you know like when to keep it in radians and when to keep it in degrees?
Oh, gotcha. So the homework question should itself kind of tell you which way to go. So say you gotta, let's see, so like this problem here, right? You have given, that's given in technically in degrees, right? And so it'll tell you what to do. But the only issue you got to deal with is the fact that our formulas are given things in radian measurements. And so if you have a formula that is used in radian measurement and you've given degree, you got to convert it.
Because in some of the ones in like 3.3 through 3.5, I would plug it in and it wouldn't be the right answer, but then I would change it to the other mode and then it would.
Oh, gotcha. Okay, let's take a look at those as we get there. I just want to make sure that we're not confused on it. Good question. Let's do that. 3.2, number 53. And Karina, you point those out when we get there.
Okay.
Okay, sine 4 pi over 3. That's the question here. Find the exact value. And so I don't want you guys to convert it to let's see, I don't want you guys to convert it to degree measurements. I do want you to sort of think about where it would fall. So 4 pi over 3, and this little guy gives it away a little bit here. That means that we're dividing 180 degrees into 3 parts. So it's almost like this. Here's 1/3, right? Here's 2/3. This would be 3/3 right over here. So 4/3 would be down here. Are we good? So at least kind of understand you're going to be quadrant 4. So the question is big angle or small angle? And so remember we have these two different triangles, right? We got this little triangle coming from the x-axis and we got the big triangle coming from the x-axis. This is the 30 degrees, which is root 3 over 2 1/2. And if the big angle would be 1/2, comma root 3 over 2. So this one's the big angle. Are we good? So in this case, it's going to be just a negative 1/2 going this way, and then this would be a negative root 3 over 2. And the sine value is the y coordinate, so we got ourselves this answer. Okay, that's the long way to do it. The short way to do it is you're going to have a formula sheet in front of you, which has the unit circle on there. Is that right? And so just look at the unit circle. You're going to locate, let's see, 4 pi over 3. And it looks like this. The unit circle's like this. And you're going to locate this one that says 4 pi over 3. And you look to here to get this little answer there. Cool. There's the easy way to do it. All right, eventually you are going to know these. By the time class ends, by the time we're in June, you're like, oh, yes, I know sine 4 pi over 3. Because it will be second nature to you. And radian measurements will be second nature to you by then as well. Okay, 53 good? 3.349. All right. Okay. All right, this one, 49, real quickly here. It says find the distance from 1, 0 to this little point right here along the circumference of the unit circle. And then it says find that, and find that afterwards. Okay. So it looks like 1, 0 is here. We're gonna form this right here. And there's my theta. And it says find the distance. So we're trying to find t first. Then we go from there. All right, the thing is, this kind of gives it away. The fact that you're on 1, 0, you are on a unit circle. And if you are in a unit circle, that means this has a radius of 1. So it doesn't matter which one you want to choose, sine or cosine. But technically, just use sine. Technically, we know this, that sine theta is equal to 0.8413. All right, and here's where we think about it again here. Karina, this one I'm going to be in radian mode because I'm not trying to figure out the angle measurement. I'm trying to figure out the length here. And remember, radian mode is defined to be the length there. So theta is equal to sine inverse of this little guy. And make sure you are in radian mode and anybody can tabulate that for me. So it's almost like the reverse way of thinking about radian measurement. Sorry, say it again, say it again.
I got 57.28.
I got 0.9997.
Okay. I think whoever said it first was probably in degree mode, probably. And let's see. Mm-mm. I'm sorry, class. Real quick, I read it. I misread it. It says I thought it says find t. It doesn't say find t. It just says if t is the distance from here to there. Gotcha. Guess what? Forget all that. All right, let's go back to here. We're just trying to figure out what is cosecant t. So if we think about this here, sorry, this is cosine, isn't it? This is sine. And don't we have relationships between cosecant? Cosecant is 1 over. Is that true?
Yes.
That's really an identity issue here. So in this case, it's just going to be 1 over 0.8415. And we go from there. Secant is going to be 1 over cosine. And cotangent, we don't want to use tangent here, but we could use cosine over sine. Okay. Are we good there? Sorry about that. Brain freeze. Or I'm just getting old. Okay, are we good there with that one? At least get you guys started here. So let me keep on going. 57, same section here. 3.3, number 57. We are trying to figure out, oh, it says just identify the argument and each function. Don't need to do anything here, I don't think. Let's see, identify the argument. So now the function, this is just an identification, more like a vocabulary thing. The function is tangent. The argument is whatever is inside. I didn't give it to you guys in lecture here. I figured as you read the text itself, you'll sort of see what that means here. Sometimes in textbooks, sometimes later on in mathematics, you'll have sort of that. You'll have those little definitions saying, hey, what's the argument of this function? And it's just the inside of that function. Okay, that was it. There's nothing else to do here. There's no simplifying or anything. Okay, good, good. Keep on going. 89 off that same section. Let me see if I can scoot it onto this slide right here. Ooh, okay, show that AE is equal to tangent theta. And it has a little whole diagram on here. 89, how about this? I'm gonna skip that one. It's an honors question, but it doesn't show up on the test itself. If we have some more time, I'll do that today. We good? If not, I can present it.
So like in our homework for it, should we just write?
Talk to me.
Oh, sorry, did you hear?
No, I didn't. It would, it glitched.
Oh, I was wondering, so then what should we write in our homework under 89? Just,
You could write skip for now. I just wanted to let you guys, or you can just play with it to see how you can work out that. I'm going to skip it just because of lack of time. There's a little bit of a piece to go there. But it is a cool diagram. In fact, if you guys can look at the diagram itself, figure 13, because it actually has all the different trig functions in one single diagram. And so that's what one of the things I want you guys to notice is all these little pieces, they have their measurement. If you look at a unit circle, there's kind of two different figures that do that. This is one right here, and there's one where you're looking at X and Y coordinates, and they give you all 6 trig functions here. So I'm going to do this for now, just so we can get through the rest of it here. 3.413. .413. It is the space shuttle hovering above the Earth. Dun, da, da, da. By the way, who's geeky enough to watch the SpaceX launches? Sorry, say again.
I saw a video of that. It's crazy.
Gotcha. Okay, so yeah, in our family, we are the geeky family. So yes, we stay up, and we've watched the last 3 consecutive launches on it. It's cool, super cool how things are being set up. I remember watching the first time the rockets came down to be reused, right? That's awesome. Just first launch of reusable rockets. And it's super cool. Okay, on with us here. Again, 4,000 is the radius of the Earth approximated here. A space shuttle 200 miles above the Earth is orbiting once every 6 hours. Okay, that's cool. So there's 200 miles above that. How far does the shuttle travel in 1 hour? Assume the radius of the Earth is 4,000. Give your answers to both an exact value and approximate value. So every 6 hours, this guy is going to go around the Earth. Da, 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 da. Okay, so I think I have my radius here. My radius is 4,200. It is talking about arc length, right? So if we break this up into 6 pieces, So that's 360 degrees, right? Broken up into 6 pieces. Tell me if you guys agree. This degree should be 60 degrees. And we're looking at this little transverse right here by the space shuttle here. So I think I'm back to this. And here it is again. I got my radius, 4,200. But my theta has to be in radian measurement according to the formula. There it is. And how about a pi over 3 and punching that guy into that. And that should be correct for 13.
So then, would you use radian mode?
Say again, Corinna.
You use radian mode on your calculator for this?
You would, actually, let's see, because you're not taking a trig function of something, it doesn't matter. The only time that you got to be mindful if you're in radian mode or degree mode is when you're doing something like this. If you're taking a trig function off of something. So that's the only time. So this one, you'd have to be in radian mode. That one, make sure you're in degree mode. So all the rest of the time does not matter.
Okay.
Okay, 13 done. 21. Let's go 3.5. 21. I think we might make it here. All right, shows a lighthouse that is 100 feet from shore. Here's lighthouse. Little windows inside it. And we know it is 100 feet from shore, straight line to the wall of the beach. The light in the lighthouse rotates through 1 complete revolution every 4 seconds. Okay, so let me do this little light right here that's coming through. Boom. That's theta. And looks like L is the length and D is the distance here. Okay, find the equation that gives the distance D in terms of time t. And find D when t is 1/2 second and 3/2 seconds. What happens when you try t is equal to 1 second in the equation? How do you interpret this? Okay, let's go with it. All right, I'm gonna go with, let's see, so every 4 seconds, and the fact that it disappears at time t equals to 1, most likely it's because you have a light that's exactly parallel to the wall of the beach itself, right? Okay, so find an equation that gives the distance d in terms of time. So if d is equal to, let's see, I'm going to go with t is equal to 0. If it's just 0 here, right? D is going to be 100. Are we good there? That makes sense there? Through 1 complete revolution every 4 seconds. So I'm going to designate this guy here to be, the light is shining this way at t equals to 0. It's shining straight onto the beach. And then, so that means it's going to rotate, the light's going to rotate this way every 4 seconds, right? So that second 1, it's going to be pointing this way. Second 2, it's pointing down. Second 3, it's pointing, and then second 4, it's back to where it was before. Are we good there?
So are you saying that like 1 whole revolution, so 2 pi happens in 4 seconds?
Yes, correcto. And so now let's build this little piece right here. Is it going out this way? Well, let me take a look at it here. Let's see, we're looking at the distance that it's made, right? It's 100 feet here, and then each time it rotates, it's going to be going off like that. And let's see. And let's see, I'm kind of I'm thinking this way here. I'm thinking that this has to be a tangent function, first of all, because notice the light breaks here, and it's going to be infinity right here. And so in my mind, the only time that I can get infinity in my trig functions is when I use tangent. Let's do this here. So I'm going to go with d is equal to tangent theta, but how do I try to see how to explain it best here? Whenever we have breaks in something, so whenever the flow of things is, as this rotates to here, that we're going to have something parallel. So notice the distance is increasing, increasing, increasing. And so it's this little angle, and d is going to become bigger and bigger, and eventually d has to go to infinity. For trig functions, when we look at them, when we get closer and closer to 90 degrees, notice the y value will get closer and closer to 1, but the x value is getting smaller and smaller, and it just jumps, basically it just goes to 0 eventually. We good? But if, try this in your calculator, 0.999 over 0.001. Is that a huge number?
Yes.
Yeah, so whenever we have a situation that happens like this in trigonometry and mathematics here, and something goes off to infinity, we normally just use tangent for that function. That's the relationship that it holds. And so there's d is equal to, let me rewrite it again here, boom. And now the question is, we just need to figure out that theta. What should we use for that theta?
Wait, why is it going off to infinity?
Sure. So the distance starts off at 100 when we're right here. And it's the beam of the light. It says how it's the here, it's the beam of the light that's coming from the lighthouse and hitting the beach. And we're 100 units away. Oh yeah, okay. So then it's where the light hits here.
Okay.
I can explain it here. D is the distance from there to there. It would be 0 here, right? Because we're no, we're not. We're 100 units away. Let me reread this here. D is, find the equation D, the light, D is the D in terms of distance. Find the equation that gives the distance D. So D is the distance from where the lighthouse is to where the light beam is hitting. So let me rewrite this as, here's my light beam here, here's the beach.
Mr. Hondia, it threw us off of the screen onto a different one.
Oh, yeah.
George is gonna fix it.
Why does it do
It's
that?
fine. It doesn't matter.
Nobody needs that.
Yay! Okay, we're back.
Cool, okay.
Yeah, I mean, that's the one place that I agree with Adobe. Yeah. Yeah, the one instance I agree with Adobe. They're pretty aggressive about it.
So when I was trying to solve it, because you need to put it like D in terms of T, I thought like just trying to turn because like you were saying D equals 100 tangent theta, I tried to turn theta into T.
Uh-huh.
So then I did oh no, I know it's not the W thing, but that's all I can think of. Omega. I did omega is equal to the angle over T, and then figured it out with like, so the angle would be 2 pi because it's the entire rotation over time, which would be 4 seconds. And then got, so that omega equals pi over 2.
Okay.
And then I went and like solved the equation across so I could find just what theta equaled. And I found that that was pi over 2 times T. If that makes sense.
It sure
And so
does.
then, yeah, I just plugged that in for the theta for like 100 tan instead of theta. It was 100 tan pi over 2 times T. And then it asked you to like solve it for when T was 1/2 or when T was 3 over 2. And so then
Totally makes sense. Just my screen is not cooperating here. Okay. I'm gonna go with it here. Let me just quickly go with the explanation for it. I think that's what you guys got here. So if you have every 4 seconds it rotates, then you have a 2 pi rotation every 4 seconds, and which is a pi over 2. Agreed there? And with that, you should be able to just plug it in. That's your rotation. And we plug into T, multiply, so that little piece there, that gives you your omega, you multiply both sides by T, and that will give you T times, which is equal to theta. Are we good there?
That's just.
can you explain it again, please?
Let's do this here. First of all, it's 44 after. We didn't get through most of the homework here. I'm going to give you guys a vote here. Vote is take test on Monday and or take test Wednesday, which. Okay, so I think I hear claps and applause like someone just won NASCAR. So let's do this here. We'll finish up homework on Monday still. And I do want to get to that one that we skipped today. And we'll finish up 5.3 stuff. We good? Hopefully I'm there in person. I'm praying I'll be there in person. And then we'll take a test on Wednesday. Okay, guys, have a good Friday.
Thank you.
Thank you. Okay, that made me laugh so much. Are we good? Silence, shaking head. I'm like, I don't think we are.